Any other questions? Like I said, my goal is to do enough of these kits, I get them in the checkout. All right, let's start with, so my process here, the link to this Google Doc is, is in Canvas. Over here is where you would sign up. Oh yeah, you already signed up for something, kit 8 and 5. All right, so good, you get the idea. All right, so let's start 8 and 5. Oh yeah, I probably get to, all right, yeah, I can get that far. All right, so let's, this is the simplest one, and so it's Arduino code. And there's a couple of projects in the lab for starter. This is particularly, okay, hardware, start with hardware, sorry. The hardware for this, I've only got one quantity. I destroyed the other. I destroyed the other board I had, and so it's basically 2 of these. Here is one over here, and I'm just gonna go over to my other second computer and plug it in over there. The big cord, don't plug it in, okay? The power cord. This is some other thing.
Which kit is this?
Don't plug this cord in.
Which kit are you demoing right now?
I highlighted it. The one, number 1.
Oh, okay.
I'm gonna go in order. The question was, what kit is it? This is kit number 1. Where'd it go? Kit number 1. Here's the smaller version. It's easier to see. There is a Teensy Arduino. Obviously, that's this one that the USB is connected to. And there is a Seed H12, and you'll see the kit numbers 2, 3, and 4 also have an H12. Okay, so this is subGHz, and the simplest kit. Okay, these 4, all 4 of these are really, really simple. Okay, all right. So just to show you how simple is, this code. Oh, yeah, you see the lights flashing? Okay, it's actually receiving packets from the other side. But let me show you the software first. Now, the hardware on kit number 1 is irrelevant. It's a PCB all soldered up for you. But for your interest, that's what's connected. There's, just a small number of pins on the seed, serial port in and out, power, and a GPIO pin to set the mode. Okay, it's got a weird power thing, this HC12, which will be a bigger deal when we get to the next one because you have to wire it up. And it says it runs at 3.3, but actually it runs way better at 4.5. And so to get 4.5 volts with a lot of current, the 5 volt, which is the USB, the 5 volt is the USB through a diode, gives it plenty of current and closer to 4.5 volts. So if you put your voltmeter on this pin, on all kits 1 through 5, on all kits 1 through 5, you'll see 1 through 4. Sorry, on all kits 1 through 4, you will see 4.5 volts. The cool thing about the bad thing about this one is you can't measure current unless you can't, since it's soldered. The only way to measure current is to measure total 5 volt current from the USB. If you ever wanted to measure current on this, there's no breakout spot for a current meter, but you could power it up with a 5 volt supply and measure current that way. Not that you have to. Okay, so this is typical Arduino crap for setting the pin numbers. Now it does have some relays on it that you can flip if you want to. But in this particular demo, the set pin, this guy up here, is pin number 2, and the input pin, that's the input pin on this system is right here. There's a jumper. I don't know if you can see it. There's a jumper on the side, which is the input pin, which is either, in this case, it's a negative logic pull-up. So when the jumper's not in, it's high. So the input in this case is high, which you'll see is sending data. And then the LED, which you can see the output. This particular guy, I found it convenient. What the basic setup is, you send it a packet across the serial port, it responds back. And so I found it convenient to flush the receive part. After I send it a command, I'll flush the receive part. That will make it easier to receive a message. So this is a flush. This flush is serial, and it's serial 1, which is connected to the HC12. Serial is the COM port. Yeah, that's this guy over here. Where's my COM port? That's this guy over here that's sending data, receiving data. All right, so setup, kind of trivial. UART to the PC for printf. UART to the HC12 at 9600 baud. Yeah, it's got 4 outputs. Like I said, the set pin and the LED. These 2 pins I don't actually have code for, but those are the 2 relays on the board. Okay, the light's off. Okay, yeah. So this is how simple the HC12 is. You'll see the exact code in the 432. You drive the set pin low. You wait 40 milliseconds. I don't know if you have to wait that long. This is setting up the baud rate. I didn't try another baud rate. Yeah, you'll learn when we get to sub-gigahertz that there's about 100 channels that you could communicate on. This is going to use channel 7. I don't know why I chose 7. They say if there's a lot of people in the room using the same channels, you may want to choose a different channel. Obviously, I got 2 boards. They're programmed with the exact same code. Okay, so they have to be the same channel. This is interesting. This is a actual lab assignment, and that is how far does it work? And it's setting up in the highest power mode. Okay, so the highest power mode is P8. Yeah. This is optional. I believe this one was optional, but it prints some really cool stuff. So I put it there so you can see it. And this one was optional, but prints cool stuff. And then you set high. Once you set high to set pin to high, then it's basically like a UART, you know, like a wired UART. Serial port in of 1 goes to serial port. Serial port out of 1 goes to serial port in, and in goes to out. So there is no you know, protocol here. So that's one of the assignments in lab 1 is to create your own protocol. Okay, so basically if the input's high, it sends a 1 or a 0. Okay, so sends a 1 or a 0. And this is the transmission, sending 1 byte out sub-gigahertz. And you can see the bandwidth here is now 1 byte per second. Okay, unless the input is low, in which case it don't send nothing. Okay, and then once I'm in non-AT mode, anything I receive is from the other friend, right? So this guy is waiting for an input, and then when he receives it, basically the 0 turns off the light and the 1 turns on the light. That's it. And then let me restart it. Okay, where's my guy over here? Let me restart it, and I'm gonna hit the reset button over here. Okay. He said, okay, fine, crap. Okay. All right, there we are. One of the cool things, you know, Texas is not a very good, okay, fine. Texas is not a very good serial port monitor, except with the exception of it's really easy to turn it on. Okay. Because you don't have to look up what COM port it is. All right. Okay, let's do it this way. So the copy, but it's not very good about editing crap. Okay. Yeah, so this is what it chunked out at the beginning. So when you send it an AT command, it responds back with a response. Any questions on that one? That one was simple. Let me go on to another one. Like I said, there's only one of them. No questions. Good. All right. So I'm going to unplug those two. Now, it turns out the 432 one kit number 1 would interact with kit number 2, but that was not what I had in mind. Okay. So stop share over here. All right. Okay. Stop share over there and start share over here. Okay. All right. So unplug it over here. Okay. Okay, so I unplugged those two. There's no box. I have to break it. All right, so there are 3 of these kits, okay? And so now I'm doing kits 2, 3, 4, and 5. Let's go put this off. Okay, stop sharing. You can't see it. No, it's not sharing here anymore. All right. I'll share over here. Yeah. Stop. Oh, can you see? No. Stop sharing. Yeah. All right. Good. I see over there. Okay, so this is kit number 2, okay? And now I'm running in Code Composer Studio, okay? And the particular, project for Lab 1, kits 2, 3, and 4 is this thing called Seed HC12. Okay, so let's open up Seed HC12. Oh yeah, there it is. It's already open right there. No. All right. Okay, so I'm going to go ahead and plug it in, all right? Because you can't do nothing without it plugged in. All right, and then I'm going to plug. I got to set. Yeah, again, this is a subGHz, so it doesn't talk to itself. So I need a second one that I'll plug into the other laptop. Again, I programmed the exact same code in both of them. All right, so just unmute yourself and ask a question if I'm going too fast or too slow or whatever. So this is Seed HC12. You can tell from the project that there's not much in here. The Launchpad file has got basically drivers for the buttons and lights of the Launchpad. Let's see, clock is not very interesting. It just sets it at 48 megahertz. This one's not that interesting. It's just got the enable and disable interrupts in it. UART is standard UART. That's just like the Arduino version. We're going to stream debugging information through what UART 0, which goes to the PC. And then UART 1 is going to communicate with this HC12. Okay, so now the hardware is a little more complicated. You got to actually have to wire 5 wires up, 6 if you. Now, in all fairness, I wired it up. You just have to wire it back up if it falls apart during transit. Okay, So before you plug it in, I would double check that these are the connections. Again, a GPIO for set mode. It's using UART2 for communication, which is P32 and P33. Okay. So, yeah, how about this? You know what this is? Are you any ARM Cortex friends? Can you see my code? Yeah. Come on, unmute yourself. Tell me what that is. And those of you who are mentally deficient, read the line right above it. What is it?
Are we just
That's
making?
like it's like a register. That's a
Yeah,
pin.
what is
That's
the
a
big
pin.
picture? Big picture. What process is this line 75?
It's a pin. You toggle that address to toggle a pin.
Yes. Yes. Why?
It's a bit banded address.
Yeah, okay, that's the answer I was looking for. Thank you, Keyshawn. But tell me why I did it.
Oh, it's a good 319K question.
No, it's a 445L question.
Oh man.
Why
Right.
do I use bit banding on my pens?
Well, I mean, if you're using bit banding, not the full register, it helps with like race conditions.
Oh yeah, totally. Yeah, the race conditions, the critical sections, the reentrant code. As you make your system more complicated, toggling a single bit, especially in something weird like this, the Launchpad 432 ecosystem uses pins in weird ways. So you got one pin off of this port and one pin off of that port and whatever. So yeah, so this removes a race condition. And we see that when I do, here's another one, right? When I do this line of code, even though the LED is wherever is that, whatever, okay. That one happens to be bit 0. But even if the bit isn't, okay, those were bit zeros as well. Even if the pin were not bit 0, you read and write a 1. You read and write 1s and 0s to that address. So this is not critical. This will not race with any other access to port 1. All right, fine, enough of that. Okay, so let's start at the beginning here. Just like the other one, I found it convenient to flush the buffer. So there wasn't a bunch of crap in there. The initialization, now you're away from the Arduino, and so now it's a little bit more, more specific. This is the alternate function register for the port. Now this is friendly but critical. You with me? If I asked you this on a test, this line of code is friendly. In other words, it doesn't affect the other bits, but it is a race condition. There is a read, modify, write non-atomic sequence there, but I don't care. Direction. Okay, so again, we're using the UART at 9600 baud on, I think it was UART channel 2. Here are the same setups, right? We drive the set pin low. We send an AT command to set the baud rate. Interesting, and then we send out the same initialization commands. Channel 7, power 8, read all input, set the set back to 1, and we're done. You can see this one here is background enabled. And so the actual communication occurs in this periodic sysdig handler. Where are you? Yeah, here. Periodic sysdig handler, that's the rate, whatever, that's a 100 hertz, 10 millisecond rate, priority to interrupt. And there's the interrupt service routine. Those of you in that had me in 445L, remember this triple toggle technique. Toggles once, toggles twice, toggles 3 times. Why?
It helps make it clear on the oscope.
Yeah, what two things can I see on the oscilloscope?
When you start and when you enter and leave the function.
Yeah, when I can enter and leave. So there's a toggle when I enter, and there's a toggle when I leave. And so you're interested in the execution time of this interrupt service routine compared to the 10 milliseconds to look at the fraction of time in this handler. Okay, got it. So it's the same sort of output, the interrupt's occurring at 100 hertz, but the output is occurring at 1 hertz. And so where's the send data? There's the send data right there. Okay. That is the transmission out to sub-gigahertz. And again, your role here in lab 1 is to provide a protocol on top of sub-gigahertz. Okay. And if using some other platform, I don't care what you do, but I want you to design a protocol. Okay. And then this is the receiver. That's a non-blocking. And you can see from the implementation what type of handler is UART1. Can you see the yellow code? Yeah. When I go to receive, how does it do it? Now, in Arduino, I have no idea, by the way. But here in the 432, since I wrote it, can you see what it's doing? How is in-care non-block implemented? Is it accessing the serial port?
No.
No.
There's just the serial FIFO.
It's just the serial FIFO. So this is interrupt driven, right? There is a interrupt handler. And why in the context of an IoT device would you want your IO to be interrupt driven?
That way it's not tying down the microcontroller and spinning its wheels while
it's not spinning.
trying
You
to do
see, it
something
doesn't
else.
spin at all, right? The while loop shall be removed from your vocabulary. Right? They should, make a C99B that has no while loop in it. Okay? Or for loop or do loop. All those are bad things. So you can see that if the FIFO is empty, it'll fail. And if the FIFO is not empty, it returns. So here again, in this interrupt service routine, you see no while loop. There's no spinning. Depending on how this was implemented. No, it wasn't. Yeah. So, and here's an interesting question. Will this block? Will this printf line block?
No, it shouldn't.
I don't know. Why? What's your proof of that?
Well, it depends how putchar is implemented, I think.
Well, putchar is eventually going to go this guy right there.
Well, in that case, if it's a while loop there, it'll block.
It'll block. Okay. And it depends on how large the hardware FIFO is on this serial channel. Okay. So it could block. Because I do believe it's only 2 deep. It's got a shift register and a data register, and it doesn't have a full hardware FIFO. So that could potentially block. Which means it's bad code. Whatever. Let's keep on Launchpad. Okay, so yeah, one of the cool things I can do is, I don't know if you like it. Okay, tools. Terminal. There we go. All right. Oh yeah, build. Debug. Run. Where'd my terminal go? Here's the terminal. Now I don't care whether you use putty or run. Okay, it didn't show up there. There we go. Okay. Oh yeah, here we go. the weird thing about the 432 is it throws two COM ports at you, and you just have to guess. I mean, 1 and 3 are my system. I don't know if it's, yep, that was the right one. I guessed the second one. Yeah, so this guy not running. Oh, I got to push the button. All right, here we go. All right, so I am pushing the button on system number 2, and it is sending 1s and 0s to system number 1. So I push the button on system 2, the light flashes on system 1. I'll push the button on system 2, and you can see it's sending. You see the S0 now, and I'll push both buttons. Okay. All right. So now it's sending and receiving. Now there's no collision control here, by the way, I don't think. You're just lucky at one. Oops. Yeah. Whatever. It's hard to get my fingers on this button. There we go. All right. All right. So I can send and receive in both cases. If you find pushing the buttons too. Any question on that one? So you can see it's not very complicated. Again, it's only 166 lines of code, right? So all right, I'm going to skip. Let me go open it up over here. So I just did these, and while I have the Code Composer Studio for the MSP 432 open, I'll do these. Okay, so all right, so I'm going to unplug everything. Okay. Unplug everything. And so now, all right, so now this is my next kit. A 432 launch pad, the one in the middle, a CC2650 launch pad. Now the cool thing about the launch pad is it's real easy to reprogram it, you know, so if you want to mess it up, there's a way to put it back, okay? This one also has what's called a Mark II educational booster, which means it's got a bunch of cool I/O on it. And the particular thing I'm going to do is make a fitness device out of it. Okay. So I got to plug it in, obviously, because you got to program it. So I need a cable. Somebody give up their cable. Okay, take it off of this one. So be careful. You want to program the 432 and not the CC2650. Plugging the cable, plugging the USB in the other one will power it up, but obviously it's not the way. 432 USBs are upside down from the TM4Cs. Right. So out of sight, out of mind, I'm going to plug it in. Okay. All right. All right, let's go over here, walk you through this one. Now it's a little more complicated. The one I want is, yeah, so let's want that one. So I want MK2 Fitness, BLE. So this is the fitness device. It's got a few more files. All right, let's walk you through some of the, this is an interesting file. This is the, board support package, the I/O drivers for that MK2. So you can see there's buttons on it, there are buzzers on it, joystick is on it, it's got an LCD, it's got an accelerometer, it's got a light sensor, it's got colored LED, it's got a temperature sensor. And so again, this is not 445L, and so this layer of software is is there for you. If you were to open up one of these buzzer set, you will see that this is 445L style code. This is Valvano type code where you can actually see registers and how it works. So the buzzer uses a hardware timer. Accelerometer uses the ADD converter. So it's not very complicated. Once we get into TI drivers, you know, or Arduino, how it actually works is completely abstract. Okay, let me show you some of the files you need for, I'm doing Bluetooth now, okay? This is Bluetooth. Some of the files you need are here okay, let me show you hardware first. Okay, hardware is fairly straightforward. It uses 2 pins for UART. Actually, the same 2 pins as the other one did. PB, not PB, oh here, P3, 2 and P3, 1. It has a reset pin, which you can reset the device. And then it uses 2 handshake pins. One is an output, one is an input. So it's handshaked UART at the lowest level. So master ready is from 432 to CC, and slave ready is from CC2650 back to, okay? And so this is standard initialization of GPIO pins. Okay, so that's a low level device. This one is a little bit higher level, and in here are the commands for establishing a Bluetooth connection, you know, initializing the device, resetting the device, setting up advertising, starting advertising, sending message, notifications. And again, we'll do all the theory of this later. It uses a process that needs to run periodically. So there is a background thread that's actually performing the Bluetooth communication. And you'll see that when we get to the main, that we're going to initialize this guy to run periodically. Okay, so I'm going to open that one. Let's get this. Yeah, so it's what are some of the, let me start at main. Hold on, let me start actually start at main. This is a little more complicated than the other ones. This is essentially a 445M operating system where it establishes periodic tasks, which are real time and run off the timer here. And it's foreground tasks, which are scheduled, you know, according to semaphores and whatever. And you can see there is no while loop here. There is no while loop. The main program ends. And you'll see this when we get to TI RTOS as well. The main program is no longer exists once you establish which threads are running. And so it waits for you to hold down a button and then initializes Bluetooth. And then now I'll show you what goes on in the background. Okay. So we saw task 1. Where's task 1? Let's go. Okay, task 1. Task 1 and 2 were periodic tasks. You saw that? Task 1 and 2 are periodic tasks, hardware periodic tasks. Okay, task 1. Task 1. Oh, task 1. That's logging. That's sampling the accelerometer. That's sampling the sound. So tasks 1 and 2 are running the sampling on the sound and the A to D converter. There's one more periodic task. You'll see it in AP. Where is it? AP in it. Is that where the Bluetooth in it? Where'd it go? Bluetooth in it. Okay, sorry. I don't know. I'll show you this one while we're here. This is the crap you got to do for Lab 2, and that is understand how these things work. What's a service? What's a characteristic? What's a notify characteristic? What's an advertisement? What's registering mean? And so right here in this one spot is really the heart of the Bluetooth connection. But there is one more. There's an interrupt which is running the background thread. Anyway, it's in there somewhere. Let me go back to the main. Okay, so we did task 0, task 1, task 2. These are all foreground threads. You can see that this is the step counter. This is the step counter. It's counting steps, and you can see it does plotting. So it's going to plot on the screen. Step 3 is looking for a button that this particular system, this operating system, just like 445M, has a logic analyzer profiler built in. Well, not built in, that you can, if you have a logic analyzer, you can profile these threads by looking at specific pins if you have a real logic analyzer. This one is a virtual logic analyzer. And you can see this implementation. Look at Texas task 3. What is that doing?
Is it just logging timestamps?
Yeah, but why?
Good question.
Well, read the comment.
Oh yeah, when the task starts.
When the task starts, you log the time. Right, so there's a whole bunch of buffers, time buffers, with certain sizes, and it just logs the time, right? So, because once your operating system is running, you're gonna, again, what the H, who's running, who's doing what, okay? And so if you have a real logic analyzer, right, then you have a real logic analyzer, then what is it doing? What's that? We did this already, man. Well, sort of.
It should
What's
just
that?
be toggling a pin.
Toggle.
Toggling a pin, you know, it's thread safe because it's bit banded. Toggling a pin. So if you had a real logic analyzer, I don't know what pin it is, but it's in there somewhere. Okay, you can look at this stuff. Okay, so anyway, that's looking at the buttons. And then task 4, again, this is a scheduler. This is processing the temperature sensor. So the temperature sensor you can see is I²C, and it shares with other events. So what is the purpose of this? If I told you I²C, the temperature sensor is on I²C, and I told you a whole bunch of craps on I²C, what's that for?
Wait for the bus to be free.
Wait for the I²C to be free, right? Yeah,
Bus.
I²C. Yeah, so that's and you can see it's got a nice name, that's a mutex, right? Okay, so temperature sensor. This is looking for sound loudness, so that's not decibels, but that's at least RMS of how loud it is. All right, and there's the light sense. Okay, so that, right? You see what I meant? Here's the other one that uses I²C. It's a light sensor. So again, every time you do an I²C operation, you got to do a mutex. Okay, that's just a, oh, this is, oh no, that's the, oh no, there it is. That's the one I was looking for. I knew it was somewhere. This is actually important. The running of this is critical for implementing the Bluetooth operation. So you can see it's a foreground task, so it's not real time, right? It's scheduled when it's scheduled. But it will go to sleep if there's, because nothing in Bluetooth can happen until there's another interrupt. Okay. Anyway, so that's enough of that. Let's build it. Okay, build. So I don't have to tell it anything about my phone. I'm going to go the other way around on my phone. I'm going to read stuff. Okay, let's open debug. I think it's plugged in. Yeah, plugged in. I want to close this terminal and open another one because it's a completely different processor. Okay. Again, I don't know which one it is. Let's go ahead and run it and see if I find it. I don't know which one it is. Yeah, there we go. All right, we're good to go. All right, so when you've got the thing plugged into the, can you see my screen, right? The bottom corner here, okay? And we'll do the gory details when we get the Bluetooth and do this example. But you can see the steps in connecting a Bluetooth is to register a service, okay, or build the service. Okay, sorry. Read the directions, John. Build the service. Okay, so that's setting up a data structure. Add the service. Okay. Add a characteristic to the service. Add a value and description to the service. Add a notify. Set the device. Set the advertising information, and then start advertising. This is when the thing becomes live at start. And so now, it reset the 2650, and these are the message protocols between the launch pad, which is the 432, and the simple network processor, which is the CC2650. Okay. And so now where's the phone? Okay. Now, I don't know if I can see if I can do this. Let's quit that one. No, I want to quit sharing over here. Okay. Stop sharing. Okay. There's a bunch of pictures in the lab manual. Okay, not Fitbit. Yeah. Just checking to see if it actually works. Where's an unnamed? Oh, come on, buddy. Come on. Come on. Reset button. Okay. Hold on. Quit debugging over here. Anyway. Hold on. Reset button. Broke it. All right, so I don't see it. Hold on. We're sports fans. Okay. All right. I don't know.
Quick question.
Yeah, go. Go, good. Questions?
Why do you hate Arduino?
Oh, it doesn't, you're not going to put it in a aircraft carrier, are you? Okay, I hate Arduino from an educational standpoint. The Arduino, okay, so I also hate LabVIEW for the same reason. I hate Visual Studio for the same reason. And can you guess why that is? Why would an electrical engineer hate a professor of electrical engineering hate LabVIEW?
It hides
Why
too much
would-
stuff.
I'm sorry, what was the question?
I mean, it hides.
It hides everything. I mean, LabVIEW, Arduino, Visual Studio, Visual Basic, MATLAB, they're perfect for a mechanical engineer or a biomedical engineer, someone who wants to use the computer to solve problems. But if you want to teach an electrical engineer what a port is, or what it means to be thread safe, you've got to get into the details. The second reason is I don't know of a lot of actual, automotive, military products that use Arduinos. Now we use it in the Abu ventilator only because we didn't know better. I mean, we wanted to get up quick.
Precisely. So this class is quick, so Arduino's okay, right?
It's okay. No. We had that conversation yesterday, and I'll repeat it for the rest of you. Arduino is probably the fastest way to do this class.
What is it any less reliable? Like if you're using it in a ventilator, like what's preventing Arduino from going into an aircraft carrier?
You supply chain, and it's not the chip necessarily. Can you certify? Okay, so I'm talking to Austin. When they send this ventilator up for a regular FDA mission, approval, they got to replace Arduino.
Yeah, but
Because the IDE cannot be. Nobody's going to stand up in court and say this works. There's no legal backup for the code. In other words, every Arduino code that you've downloaded, there's some sort of disclaimer, you're on your own. Whereas when you spend $10,000, $50,000 on a package from some real company, some lawyer's going to go into court with you when it doesn't work and tell you it's certified.
Okay.
So, and when you go out to work and you're working for, General Dynamics or Lockheed Martin, they're not going to let you use an Arduino.
to be fair, the ventilator started out as a guerrilla engineering project
Yeah.
that anybody could make in their garage. So
Yeah, that's what it was for. It was perfect. Okay. I got an idea. I got a backup plan. Hold on. Don't go away. I just stepped on the. I'm sorry. I'm stepping on the poppers. I put the poppers in front of my door during Halloween. Just okay. All right. So. All right, much better. All right. So now, okay, so back. All right, so just to finish this demo. Okay, I don't know if you can see. Do I need to reverse it? Can I reverse it?
You can see it just fine.
You see it fine, but it's backward for you, isn't it? Or is it not?
No,
It's
it
not
only
backward.
appears backwards for you.
It's only backwards. Okay, I'll deal with it. All right. So somewhere in the code, it's called Shape the World. Okay. Oh, I have. Oh yeah. Sorry. I'm light blue. I'm running light blue. Okay. That's what I'm running. And there's one for the Arduino too. All right. So there's Shape the World. If you were to look at the device, it's a step counter. It's not doing, you can see the light turning colors. It's counting steps. All right. And so there's a sound, there's a light sensor. Okay, so Shape the World. So I'm going to push the Shape the World button and it's going to connect. Okay. Oh, I should be showing you the serial port. Oh, yeah. I'll show you the serial port. Okay. So, stop that. All right, so stop this. Oh, let me push some buttons here for a while on this while I'll show you here, and then I'll hide video back up. Okay. So Shape the World, and so you can interact with the services that we set up, the sound, the temperature. So let me just read the temperature. So there's the temperature characteristic. And then I'm going to go read characteristic. And there it is, 1B. Okay, yeah, I know. My cell phone is really pretty. There's a 1B, which is the hexadecimal temperature in centigrade. Okay. Let me share the screen and show you what it looks like on the serial port. Maybe the next one. There we go. Can you see my screen? You see my screen. This is the same sort of stuff we saw when I was running on the other computer, but every time I request, so I'm going to push the read temperature button, and you will see that the phone asks the device for temperature. So embedded in those codes are, I want the temperature, and embedded back is the temperature. Okay, you can see that. There it is, read temperature 1B. Okay, I'll push a different characteristic. Light. Okay, so I'll read the light temperature. Okay, so I'm reading the light temperature. Let me do an output. Okay, where's my output? Okay, output is plot state. Okay, that's an output. Okay, so plot state is a two-directional characteristic. So I can read the plot state or I can write the plot state. Okay.
Are you using a generic app?
Yes, I'm using light blue. Okay, light blue is download. You don't have to write it. Okay, so to do lab 2, okay, I anticipate you'll run some generic app that is already done for you, so you don't have to write it. Okay, but you can see. Oh, you can't see. I changed the plot state. Okay, so you interact with your. So the code is a little more complicated than lab 1. All right, let me do some hard ones. Are you with me there?
So are you just sent from the phone? Or are you just sending like integers to the Bluetooth?
Yeah. So okay, you can't. Okay, so let me do it again. I pushed write plot state, and there's a little window right there, and I'm going to type the number 2 down here. I don't know if you can see. Little keypad. Yeah. And then it's like enter, done. And that sent plot state 2. You actually heard a beep. That was beeping on the device.
So what's the goal of lab 2?
I want you to understand service, characteristic, advertising.
Can you explain that really quickly? Just like
no, because that'll take me. I gotta take me 2 weeks to explain Bluetooth.
Do we have a lecture on it?
Yeah, you have 2 weeks of lecture on it. The purpose of today is to show it running for you so I can take them into EER and get them for checkout.
And then for Bluetooth, is there a client server?
Yeah, sure. Yeah, absolutely. This is the server. That's the client.
But you can send information both ways, correct?
Of course I can.
Okay.
Did you see the plot state? Did you see the variable plot state right there?
Yeah.
I can read it. I can
Oh,
do, if I push the read button, right there, you see I read plot state. You see that? Read plot state?
and then you're pushing the button on the phone or the.
No, the phone is the controller. Now there's another one called notification. Let me do a notification. That's steps. Okay. Let me listen for notification here. This one is now, so the sending of data, the phone can say read write, or the phone can say, no, I'm interested in something. And so now I'm going to shake it. And I'm not pushing any buttons here, right? I got nothing but steps. And you see the data getting bigger, 1A. That's the number of steps. 1E.
Oh,
Yeah, I'm walking with my thing, logging the steps onto the phone. And those numbers are showing up on the phone. I mean, I'm not a very sophisticated system. So the idea of Bluetooth is to pair, so it's a personal area network, right? Nobody but me and my machine, my phone and my fitness device are listening here. But it's a way to pair two devices together. Fairly low bandwidth, because this is Bluetooth low energy. So I want you to understand all the steps of Bluetooth and, twiggle a little bit. And if you use Bluetooth in your project, yeah, then it gets more complicated. Can I go on to another one? This is a fairly fun lab because it's got cool IO. This is not a bad environment because it is both open yet exposes some operating system stuff. It's got lots of IO. I don't know. What else can I tell you? All right. Let me go on to another one. All right. You be quiet. All right. So unplug you. Stop share. Stop that. Okay. I got to turn that off. Turn that off. Stop share. Turn this off. All right. So next is this one. So this is kit now. Okay. Let me share over here. Share over here. Okay. Still up? Yeah. No, not that one. This one, this one, not that one. This one, this one. That's just me. Okay, so I'm going to do these now. Okay. What are we doing on time? No, I may not. I may not get them both. Okay, but this kit is going to have 2 launch pads and an extra machine. And this is they're all CC1352s, but this one has a bunch of sensors on it. And this one here has a bunch of sensors and a place to put a battery in it. It has a bunch of sensors and a battery compartment. That's what this is. All right. Which is probably not meant for lab, but could be used in a Bluetooth project. Okay, so this has got cool sensors on it, but I got a pile of them, so I'm going to put them in the kit. Okay, so for lab number 1, you're going to need 2, okay? And so, oh, I think I got it programmed in here. So I'm going to plug one in over here. Oh, yeah. And I'm going to plug, ooh, I got it. Which one's which? This one, okay, let me go back to Code Composer Studio. This one, you're going to program something different in each. Okay, so I should have labeled them. I'll figure out once I don't know which one this is. All right, so I don't want the 432. I want this. So there'll be a separate install for this one. As a matter of fact, the code for this one you download from the TI site. Oh, where do you go? I guess it's going. Okay, there it is. Sorry. All right. So to do labs 1 and 2 on this platform are basically these 4 projects that I downloaded from the TI site. The directions are in the lab manual. Actually, directions are on the internet. But I'm going to do lab 1, which is 2 separate devices. One is a collector. In other words, it is sort of, think of it as star network. You have one collector and multiple sensors. So again, for lab 1, you'd only need 2. If you want to do a project, we can get you more of them and you can have more than one sensor. Okay. So it's a little complicated. All right, let's see. Let me program that. Let me think I'm programming the sensor. I hope I am. Okay, so that's okay. I can't figure out which this is. All right, so you remember we called it subGHz in the last one. Now we're going to call it TI 15.4 stack. They both exist in the IEEE something 15.4 protocol. And so so there is it is subGHz, right? And this particular protocol is running at 915 megahertz. There's the PHY type. Okay, network settings. There's the channel. You remember we set channel 7 on the other one. This is going to do a scan of channels 0, 1, 2, and 3. Whatever. Power setting. Okay, transmit power. No, it's somewhere else. Power channel. So anyway, in here you set this up to communicate. You can see this device. Keyshawn was asking the other day, could you take a single platform and do multiple labs on it? Yeah, we're going to do on this one chip, we can do labs 1 and 2, but you could also do for lab 5, open thread or Z-stack. You know, there are all sorts of other protocols that I don't know how they work. But it's in this one that we set the Wi-Fi protocol. And then there's another one. Where was it? Application? No, that I'm going to get in there. Okay, so sensor. Okay. There's another one. Hardware stack, software stack. Already configured. Yeah, that one. Yeah, okay. So in this one, we set the individual device. So again, this is all listed in the TI stuff, but my point is once you're in this environment, you do more than program C code, okay? All right, so it's possible I have the boards in the wrong order. You can tell it's running TI RTOS, and so let's look at the main. Yeah, let me start with main. That's always a good spot to start. Main. It is a lot more complicated, but a lot more powerful. Main, where's my main? Main, okay. Just like all the other ones, the purpose of main is to initialize the board, initialize the operating system, initialize. This is the crap you do when you in TI RTOS for configuring a background a foreground task. You set its priority. You set its you set its stack, you set its function, and then you can do a whole bunch of them all in one structure. And then here at the end, just like the last lab, once you've configured your threads, you launch it. Now, one thread can launch another thread. So let me zoom into what actually happens, and that is build message and send message. Okay. Okay. Process message. Now I want build message. Build message. So build message. Process sensor message. Message. Send message. Send message. Sensor send message. Some other process. Maybe that's what it was. Yeah, sure. This is this thread here is this program here is creating the protocol. Remember, in the last one we sent just bytes. Here it sends a whole bunch of bytes, and so it's filling up this this structure. It's filling up this structure with a bunch of data about the devices. Now, lipstick is this guy, and so this particular code will work on both the launch pad and the lipstick. Okay, so and then send right here. Read, no, it's read. Where's send? Read sensors. Oh yeah, maybe read sensors. Where's send message? Yeah, there it is. Send message. Okay, and so this is the place where it is creating the message. Okay. It's creating the message, and somewhere down here it makes it happen. Okay, a bunch of crap happening. You can see it's way more complicated. Down at the bottom, there you go. Boom, out it goes. Okay, so there's okay. So there created the message. Here it sent the message. So let's open up send message. Send the message down. Yeah. So here it's actually sending the message. All right, so yeah, run. Okay, so I don't know if this guy, if I got the right guy, I'm the right guy. Build. Yeah. A 50-50 chance this was good. No, I win. Okay, I win the internet here. Okay, so now I'm running on the sensor. On the sensor device run. Yeah, terminal. And just like the other one, a bunch of crap comes out when you run the terminal. Run. Open. Okay, so local terminal. Yeah, I don't know which one it is. Yeah, there it is. You see down there that they are connected to each other, and so pushing buttons on one triggers crap on the other. Here's what now I'm at the end of the time, and so I think what I will do is don't put them all into checkout. I think what I'll do is I will leave one back. No, we'll leave one of these back. Yellow. That way I can demo the lab 2 or re-demo lab 1 when I talk about the theory. Okay. So my plan is, any questions on anything here? I'm at 1046. I'm gonna put them in the boxes. The boxes are gonna be numbered 1 through, well, 15 eventually. Lab 2 is another Bluetooth option, which I haven't demoed yet. So maybe I'll demo this one on Tuesday. And it's a fun lab because your phone can control the robot. Okay. But I seriously haven't gotten Lab 3 to run on it. I ran years ago, but so that's my current plan here. Now, like I said at the beginning, if for some reason you feel safer not coming to campus, yeah, let me know and I'll mail you one. I don't care. You can do the lab and then send it back. I'll mail it back. Okay.
When will
Questions?
the Wi-Fi lab come out?
Okay.
Or just the instructions for it? Like not
Oh,
the-
instructions. Okay, fine.
like the deliverables?
Yeah, I know. Great question. I got last night at 1 o'clock between 10 o'clock and 1 o'clock in the morning, I was trying to get this done. And epically failed. Lab 3.
Have you tried Arduino? It's magic.
Yeah, no, I don't want to do Arduino. I don't care. But you're right. When will the instructions come out? Fine.
Yeah.
I got instructions for 1 and 2. Come on, man.
Just,
I-
just,
I get what you're asking.
Yeah.
I know what I can do. I can write you a Lab 3 generic lab report.
That's great.
Yeah, that's doable.
I'll figure out the rest.
And then, there's certain, just like the question Austin asked, what do I want you to learn with Bluetooth? There is sets of questions I want you to learn with Wi-Fi.
Great.
Yeah.
Yeah.
Yeah, and yes. Yeah, as a matter of fact, what I can do is write you a generic Lab 2 assignment, assuming it's not one of these protocols. I'm sorry if I forgot. Is someone doing subGHz with some other chip that's not one of these two, the HC12 or the 1351? I forget. Yeah, you guys talked to me and I don't remember.
Oh, what are the @ command? Is that just like a special protocol to program stuff?
Sure. Yeah. Okay. Fine. Let me do it in. Yeah. Sure.
And like, what are drawbacks?
I get it. Let me just answer. Okay. Let me see. No. Did I do that wrong? Whatever. The AT stands for attention. This is a protocol built in the 60s, by the way, that, people are gonna, it's a fairly simple, approach. The ESP devices used it. The Zigbee devices that we have somewhere in my office, I have Zigbee modules. It uses this same type of protocol. It's a string that begins with AT plus. And it's called either AT or attention. And it means command. Okay, so not communicate, but configure. And then the rest of the crap is specific for that particular module. And this is HC12 communication.
So if it's like serial, so if like, what if the baud rates don't agree at the beginning? How do you figure out?
Oh, come on. That's a 445L exam question. It won't be an IoT exam question. But since you were in 445L, I get them, you know. Okay, open up the answer to the forum. All right. Phone a friend. Who wants to tell them how two devices which don't know each other but are connected with a serial port can establish a common baud rate? We have the nice one and we have the stupid one, okay? So ignore the stupid one for a moment. The stupid one is running at a baud rate that nobody knows. In this case, the MSP 430 is the stupid one, okay? If you're the smart person, what are you doing?
Well, if you had some defined protocol, you could theoretically sweep the common baud rates and see if one of them is responding.
Okay, you could. Yeah, absolutely. That may be actually how this one works. Is it basically says hello, 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 hello over again until the smart guy sees the letter H by sweeping the baud rates. Yep, that's one way to do it. That's probably the way it does it, because there aren't that many baud rates, and he's right. The standard baud rates would probably be, or in this case, it's probably programmed for two, one or the other. How else could you do it if you were a 445? What?
Find a manual.
No, some bozo programmed it and never updated the manual.
So with sweeping the baud rate, I mean, what if the parity bits and the stop bits and all that stuff is different? You'd have to sweep all those as well, right?
Yeah, you would. Yeah, but nobody uses the parity bit anymore, and the stop bit don't matter, one or two. Okay, just saying. Again, the parity is something that happened in the 60s when serial protocols actually threw lost bits. But when you send bits from one board to the other, no bits get lost. 445L question. One of the labs that had nothing to do with serial port taught you a thing you can do on a microcontroller that would answer the question, what is the baud rate? If I looked at the incoming serial line, what measurement would you like to perform on that wire to determine baud rate?
Would you just look at like the period, like you do like
Sure,
input
well,
capture?
period is probably a little weird because
Do like
it's
an input capture to find
input
the-
capture and measure pulse width.
Yeah, that's what I mean.
The minimum pulse width on input capture, and assume that bad boy doesn't send you, 00110011. They send something with a small pulse on. Yeah, sure. That's what a smart person would do. Yeah, auto configure. The same way, how do you suppose if this guy if these guys are sending and listening on 4 channels at a time, like we saw that in this last example. If I set up 4 different channels, and can you guess what a channel is?
Just a wire that you can input and
No,
listen
it's a
to.
channel. No, blah, 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 blah.
The port?
No. There's a board here and another board there, and they're communicating through channels. On the HC12, I set up channel 7, by the way, and
Yeah,
on these two, it sets up channel 0, 1, 2, or 3.
Is it a different frequency?
Different frequencies. Yeah, it's
Like
around 915 megahertz, but the sub frequencies, the sub channels, are little narrow frequencies that it will communicate on. And so how do you suppose it figures out what channel to run? If they both say, it's either 0, 1, 2, or 3, I don't know, but one of those.
Doesn't it scan like your radio?
It's going to scan it. Yeah, that's why it's way more complicated. Okay.
So for the H12, like it's pretty dumb. Like it doesn't send you anything, right? Like I was experimenting with the baud rate. So like if you set it to like 115200, right? And then like you use your starter code, which is like 9600, then it's never going to work. So do you just continually change it on like your smart device's end and keep on like pretty much bit bashing it with like commands until it works?
Okay, now I
Because
don't
the
know about
H12
the,
is
I don't,
pretty-
I do not know about the HC12. I do believe on the HC12, I did exactly what Austin said. I looked at the manual of the HC12 and it said use 9600.
As a
Okay.
default, yeah. But if you change it, it'll remember that, and then you can't use your starter code anymore. So like if you like brick the chip, like okay,
Ooh.
if some other student, right, returns the lab and it's at 11.5, like it's gonna be a pain for them to, you know what I mean? Like
I do know what you mean.
so, and it's a dumb
okay,
chip.
now-
It doesn't send stuff automatically. Like you have to send it an AT command and they'll send something back. But if it doesn't agree on the baud rate, then
Could be. Could be.
so is that the solution? Do you just like go
I have no
AT
idea what the answer is. I
9600?
understand that you can brick things. Okay. Yeah, that I understand. Oh yeah, as a matter of fact, one of the things, one of the cool features on the this CC1350 is the following mode. You hold the reset button down. You hold button 1 down. Where's button? Which one's button 1? Button 1. Hold the reset button down. Hold button 1 down. Leave button 1 held. Let go of the reset, and it'll restore factory settings, because they know that you're an idiot, right? And they don't want to have to sell you another one, or worry about, So this one here has a factory reset process, and it will relaunch this guy, ignoring all the settings that you programmed in it, because normally you would program the settings, shut the power off. You want all the settings to be there when you turn it back on again.
Yeah, there's I guess on the HC12, I just looked it up. If you hold the pin low for the set and then you power it up, it will factory reset it.
See, fine. See,
So it's idiot.
they know you. They're anticipating your adventure. Okay.
I'm just saying, like for other students, I had that problem too because I set it to some baud rate and then my serial.begin was like 9600 and it never worked. And so.
Okay, so you just told me to. All right.
So keep it at 9600 if you want to.
No, we'll just teach them how to. We'll teach them how to reset it. Fine. Okay, so what did you do? You did.
Let's see. I can post it in the.
Okay, so pull. Now push or pull.
So
Set.
hold set low.
Hold set low.
And then it says delay in parentheses. So just, pretty much hold it low and then power up HC12.
Okay, so power off. Delay that. Why do you need a delay? And then you power on.
Yeah, and then it says maintain set low. The interface should now be default, and then set commands to configure it, and then take it high. So if you power it up with it low, it'll go to default pretty much.
Okay. Maintain set low.
Until you have.
Then you send the AT command to set baud rate.
Yeah, and then take it high. But it'll be 1900 at the beginning. That's important to know.
Whatever, 9600.
Yeah.
And then set high. Push. That?
Yeah.
All right. 2, 3,
But you should put in it will reset to 9600. So you can initialize to that and then
Oh, yeah, you said no, it will be at, okay.
then if you change it, then you have to change your serial as well after that.
Yeah,
So I
got
don't
it.
know. Kind of.
Yeah. So,
Here's a question. So right now, I mean, I did lab 1, but I'm bounded by the baud rate.
I don't care.
So can I write that in the lab report? Is that
Of
like,
course.
okay.
No, I don't, there's no, so that, what, was this you, Keyshawn? I couldn't see. Was that you said talking? There's no right answer. I want you to know what baud rate is.
No, I
I
know,
want
but I think the frequency can go faster, but I think
I
I'm
don't
bound by
care.
Okay.
I mean, there's not a competition like, Survivor who can do it, who can send the most data. It's just, I want you to know what bandwidth is. I want you to actually measure it. I want you to know what it affects it, but I don't care what it is. This is the low bandwidth one anyway, right?
Yeah.
Yeah. All right. I'll put it in the other one too. Just in case you- Because it would, since it's the same chip, it ought to work here too. So, all right, we're way past time. Any other? So you're welcome to. Yeah. So checking it out for a week seems like a reasonable amount. Yeah. Any other questions? So I'll continue my my CC1300 with on Tuesday, but I'll leave some and check out so that you can use it. This has got a cool demo too. This one's demo on this bad boy is really cool when you get the Bluetooth. Okay, well, take care. We'll see you on the. I apologize for those who came to office hours yesterday 11. My office hour yesterday was at 12. So always go to Canvas to figure out when my office hours are. All right, take care. All right. Okay, stop share. Quit, leave.